Good morning, everybody. So I'm a residence structures expert in the Rotorcraft certification department. And today I know that we have here almost 13 STC Rotorcraft applicants. I think it was actually a good idea to dedicate a presentation to Rotorcraft. So I would like to convey a message to say that the objective of the Rotorcraft department is to work on safety in a very proactive manner. And to do that, we cannot do it alone. We need to work side by side with applicants, including STC holders. So we need to share our views, we need to share experience, difficulties, and also to inform you when we are trying to develop some guidances to help you. So I hope that you hear me because the microphone, I have to get closer to the microphone, yeah. So this presentation actually is for structures. And in this presentation, I would like to share with you most of the issue and complication that we have experienced when dealing with STCs. The objective is also to bring STC holders to anticipate those difficulties before the application and think about those difficulties when designing a change. And it will really improve the chance of success for STC applications. So it is not a very technical presentation because I think everybody is hungry and need to go to have some food. But the idea here is to repeat what we have presented also at the STC Workshop a couple of years ago, where very few STC applicants were attending, particularly for Rotorcraft. And today there are more applicants attending, and we would like to bring this message across a wider audience as possible. And of course, we want to keep the communication channel very active. So which kind of STC do we have in structure in general? Globally, STCs are related to internal devices installation and external devices installations. So we have internal devices installation like avionic equipment, seats installation, control station, medical equipment. So most of those applications can be found in HEMS, helicopter emergency medical system applications. We have also external devices that can be split in two categories. External loads, for which there is a dedicated requirement, H65, and external features. Down here on the, it's on the right-hand side, you have actually an example of external load operation. It can be done by cargo hook, cables, but also by hoists. Sometimes you have also platforms involved. External load attachments and applications are jettisonable. It has to be differentiated from external equipment installation, external fixture that can be lights, antenna, cameras, mirrors, and they are not jettisonable and they have limited payload capability. Just something important to know, any applicant applying for a hoist development or a hoist installation will have to contact EASA because today we have issues with the existing and available hoist. They have a non-compliance issues that any applicant applying to install a hoist through an STC have to know. So, of course, more pictures than words, but here I wanted to express the fact that STC holders might tend to see their application at EASA as a long marathon before having a technical visa. We would like to break this idea and to move to something more practical. And again, as I say, we would like to work side by side with STC holders to help to shorten the duration of this marathon. So, as you can see, you agree with me that this marathoner really compromises his chances to finish the marathon or to make a good performance, because this marathoner is heavily equipped. He thinks he needs everything that he puts on his body, but at the end it will be so heavy that he will have difficulties to make a good performance. This metaphor actually can be also applicable to STCs in some cases, because STCs are looked at often very locally, and not often STC holders are capturing the impact of the STC at Rotorcraft level. And this can compromise or put STC holders in very much difficulties, and the obtention of the technical visa can be long, can be done with limitations, and we want to avoid that and to anticipate issues, as already said. So we have actually at EASA, we see general issues that I wanted to share with you. So often the STC's boundaries are not very clearly defined in applications for several reasons, because the STCs are combined with already approved STCs or already approved SBs, and it's difficult if the applicant doesn't indicate clearly what are the STC boundaries. It's difficult sometimes to know it, and it takes a bit of time to understand exactly what is the STC, what is the added value of this change. As I said, impact at Rotorcraft level has to be evaluated, and often, I think this is clearly the case for many STC holders, there is no or few OEM data available, and therefore similarity, reverse engineering, or engineering judgments are often used, but they cannot be used for every compliance demonstration. So in many cases, the design organization technical capability can be a question for some demonstration when, for example, you have to perform additional fatigue assessment, fuel tank assessment. Those are not possible for STC holders, and probably the budgets do not allow them to do that. So what happened is that we have a level of involvement that is particularly high very often. So there are also some design precautions that we would like to recommend, and the small picture that you cannot see, sorry for that, is an accident of the Air 44. And this rotorcraft lost control because there was a nut that was a defective standard fasteners installed on the control chain, which failed, which is the nut that you can see, oops, here. So many of you have already been informed about defective standard fastener issues, but we would like to point out that not only TC holders are concerned, STC holders can be impacted, because we have actually issued an SIB to help identifying the fasteners that were concerned by quality issues. But in general, it's not recommended to use standard fasteners in critical installations. And what we mean by critical installation are installations, the failure of which can be catastrophic, but also hazardous. And an STC can have hazardous consequences on a rotorcraft. So the recommendation is not to use standard fasteners in those installations, to use qualified fasteners, and when they are not installed in critical installation, therefore, it is recommended also to have inspection means, just to capture issues if they are entitled to arrive. So often we have also a dual lock that is requested by regulation for fasteners, which is a good practice to remember. And what is important is also for heavy equipment installation, fail-safe capability is always a good design practice. So I put here some consideration for composite structures because we have issued in many certification memos that have been published, or some of them are still proposed for comment. There are guidance on composite database, bonded structures. There is also sandwich structures. So you will have the list at the end of the presentation. Please have a look. they are designed for sure for critical structure, but the design practices are also good for STCs. And often, what is often problematic is the design values that are the design values that are used for composite, and sometimes, let's say, the reduction factor due to environmental condition are often forgotten, or applicant question what to use. So there are some guidances that can be helpful at EASA and on our websites. Last point, but not least, additive manufacturing. I think there was a presentation on additive manufacturing. Novel, it's novel. So it is also for you and for us a novelty. And therefore we had an application with a part made by additive manufacturing in primary load pass, and the applicant wanted to have an approval within 2-3 weeks. It is not possible. This requires investigation, a lot of compliance demonstration. So if you have a novel design, please consider that in your planning that it will be a more extensive process than a usual STC. So now I'm going to address a couple of items at STC level, and after it will be at Rotorcraft level. Please consider it as a checklist of things that you might want to check and to verify. So about loads, for external equipments, will be the first part. Generally, external equipments are designed by aerodynamic loads at high speed, and by maneuver, gust loads, during condition, which we call inertial loads. They have to be put at ultimate, which you know, but many applicants decide to use emergency landing conditions to design the system that are external to the rotorcraft. Generally, 561 is usually for occupant protection, so inside of the cabin, behind the cabin, or under the cabin. So it is possible to use them, because they will be conservative, but pay attention that in some direction they are not covering aero loads or inertial loads. They can be lower in some cases, so this comparison needs to be done. I think most of you know that because we have repeated it enough. And don't forget special factors that can be necessary to cover wear and tear, fitting, bearing, uncertainties. So usually for interiors or frequently removed equipment, it is recommended on part 25 to use a 1.33 factor to address wear and tear. In 27 and 29 requirement, there is not such a requirement. So by default, we are suggesting to use the same factor. But I must admit that 133 has been used, but 115 has also been used in the past. But we strongly recommend to use 133 for wear and tear factor. And actually, there is a certification memo on part 25 that is actually making this recommendation. I don't know why it has not been issued for part 27 and 29, but probably in the future we have to improve that. About static substantiation at STC level, of course, a lot of analysis are used when considered reliable, and in case of uncertainty, tests are often required. Please keep in mind that if you are using an NTO, a non-technical objection from an OEM, a yes or a no is not sufficient. We need to read the compliance demonstration through. So it has to be a little bit more elaborated that I showed the system to the OEM, he agreed that there's no issue, the margin are acceptable, this is not sufficient. So another subject that is always missed, often missed, is about fatigue. And here you have just a little sample of fatigue initiation, propagation, and static failure due to the section reduction. So often on a rotorcraft, applicants of STC try to avoid primary structure as much as possible. But it's not all about primary structure, because the STC itself is loaded, if loaded, can cause fatigue issue and actually can be lost in flight if it fails. So, but today the requirement is actually more specific for external loads application with human cargo. And also some guidance are provided for non-human external cargo attachments. So if there is an external operation under the paragraph 865, which actually is associated to specific operational rules, there is a need to perform fatigue on what we call the personal carrying device system, going from the rotorcraft to the individual. And to lose one person that is overhang out of the rotorcraft is considered catastrophic, even if it's one person. So the requirement asks for fatigue evaluation. And as you know, when somebody is doing external cargo reparation, you have a harness, and they are not metal parts. So therefore, we have developed a certification memo to give an equivalent compliance demonstration for non-metallic component of simple personal carrying device systems. And it is in the certification memo, CS, a bit back. It is in the certification memo. This CS 0505 for BCDS. So when there is the failure of a system can compromise the sound structure, and if there is a risk for the rotorcraft, a hazard for the rotorcraft, fatigue needs to be evaluated. And this is why it is required for non-human external load attachments, when you have actually payload to bring from one point to another. But it's also required, it will be also required for external equipment for which the failure can be hazardous to the rotorcraft. So for fatigue evaluation, we have, of course, guidance in the requirement and in the ACs 27 and 29. So now I'm going to talk about the impact of STCs more at rotorcraft level, which implies, as you know, load, static, fatigue, but also vibration, burst strike consideration, ground resonance, and fuel tank crashworthiness is a concern of today. There is also ground clearance issues and potentially a ditching problem because if the option is requested. So this is not a European rotorcraft. This is a MI-10. It is a sky crane, heavy load carrier. It has been designed actually for those kind of transportation and use. And in the case of STCs, often we have rotorcraft that has not been designed for additional application and loads that we can envisage. So there will be, if we install heavy loads on the rotorcraft and at some location, a change in load distribution for the rotorcraft itself, for the rotorcraft structure, and depending on the mission, the spectrum can also be affected. So the applicants of an STC have to question on whether the substantiation of the aircraft itself is compromised or has to be reevaluated in terms of static, fatigue, and not only locally, but along the load path. So what happened is that at the end, sometimes the STC justification itself is much less extensive than the aircraft justification. And here we are starting to have issues because an STC applicant do not have the financial means to substantiate largely the carrier. You can have load issue, weight and balance issue, the flight spectrum can be reconsidered. Affected PSC will have to be evaluated. New PSCs, primary structural elements, can be also identified. And the instruction for continuous airworthiness of the rotorcraft can be affected. And at this moment, sometimes some compliance demonstration cannot be done without the OEM contribution. And of course, it has a cost. So this can also compromise the chance of success of an STC. Vibration. I think most of those who have been in contact with EASA for rotorcraft STC have always been bothered by vibration. For sure, it's a rotorcraft. There is a rotor, a certain level of vibration. The vibration mode of the equipment installed has to be evaluated, and also the risk of coupling with the rotorcraft rotation frequencies have to be also identified. So generally, we do bank tests to identify the natural frequency of equipments when they are heavy. And when they are light, some might question on whether it's necessary or not. I gave you for this purpose an example of an antenna installation along the tail boom and the pylon of a rotorcraft. Very light, nothing amazing. But when evaluating the natural frequency of the antenna, 3 points appear to be close to the natural frequency of the rotorcraft along the tail boom here. And the level of acceleration were high, but reasonably high. After the applicant decided to go and do flight tests, measured flight tests. So what we can see here on the right-hand side is a peak of 18 Gs that has been measured on the vertical part of the antenna in flight, which was not identified by the ground test, the bank test, and which could have been identified only in flight. So after that, what to do? Basically, the requirement asks to minimize as much as possible the level of vibration. So you might think that there's a need to modify the structure, make it a bit more flexible, just to be less responsive to vibration. But what was done is to evaluate the impact on static sensation and also on make a fatigue analysis to evaluate if at the end an infinite life or a limited life can result from such an excitation. And this is also a way to proceed to cope with vibration issues. So in order to provide you more guidance, we have developed an FAQ that you can find on the EASA website here that is explaining that vibration has to be evaluated not only at equipment level but also at rotorcraft level, and what are the possible means of compliance. Bird strike, of course, some aircraft some rotorcraft are compliant to bird strike requirement, not all of them, and you know that Part 27, CS27 rotorcraft are not compliant to bird strike, and even CS29 rotorcraft are not compliant for those that have been certified after 96, before 96, sorry. So the issue is that if an equipment is installed next to a windshield, next to a nose cone that has been shown compliant to bird strike, there is a need to identify if there cannot be a subsequent effect that could compromise this compliance. So basically, if you modify the nose of the rotorcraft, if you have an equipment that can impact this nose and bring more weight to the birds, it can also be problematic. It can be sharper as well. So this has to be evaluated. Ground resonance is often a weird issue for STC holders because, of course, the basic analysis are often done by the TC holder, and this is something that can be also questioned for skid landing gears, for an example, when equipments are installed on those skids. So the performance of the undercarriage can be also put in question because the undercarriage has been subject to a limit drop test and a reserve drop test that has shown some absorption capability. And when you increase the weight of the skid landing gear, the compliance demonstration can be also put in question. So there is a need to evaluate if where the item of mass is installed, if this is problematic or not for the landing gear capability. And there is also two other subjects that matters, because when an equipment is installed on the lower section of a fuselage, it is necessary to evaluate if it's close or not to the fuel tank. And here you have actually some pictures on how the position of the fuel tank has evolved with time. And you see that the lower section of the fuselage is often used to install fuel tanks. And therefore, this is also the ideal location to install heavy weight hanging underneath the rotorcraft. So when installing an STC that is stiff, a stiff structure, a heavy structure, we have issued a certification memo to indicate that compliance to the 952 requirement, the crashworthiness capability of your fuel tank, has to be reconsidered, and to understand if this equipment installed can be a threat for the fuel tank. So as I said, there is a proposed certification memo on this subject. It has not been released officially because it's going to be merged with another certification memo on the more global subject of 952 to take into account consideration for platforms, for definition of the test, installation, and so on. So you will see soon coming on the website a new certification memo for fuel tank crashworthiness that is also including external structures or external equipment installed underneath the rotorcraft or at the vicinity of the fuel tank. There is also an ARAC working group that is ongoing on let's say, occupant protection, and it includes some consideration for fuel tanks because there are a lot of accidents where you have actually post-crash fires due to fuel tank failure and ignition, for sure. And it is possible that some level of protection will be applied in a retroactive manner, and it might affect the STCs that are already actually approved without any need for compliance for 952 because the rotorcraft was not compliant. Therefore, it might impact significantly STC holders. So this will be also a big challenge. Move on. So ground clearance has to be considered because also if in case of hard landing, the equipment can impact the ground and also have cause damage to the rotorcraft. I'll speed up on this one. You have guidances in the MG6. And ditching, when installing equipment underneath the rotorcraft or in the lower side section of the rotorcraft, those are positions where you have equipment for ditching. So you have to check if you don't compromise this capability as well. For internal installation, I just wanted to put some highlights on items that are of interest. First of all, the seat track installation. Often there is a need for adapters to position the seats where it's needed on HEMS installation, for an example. And often it doesn't correspond to the seat tracks of the OEM. So I think there was a presentation on the seat adapter plate, or probably it is coming, I don't know, in the schedule. Basically, the question is whether the seat adapter plate is later. So you will have a presentation. Yeah, cabin safety adapter, yeah. So there will be a need to know if the seat has to be tested with the pallets or the adapter plate or without. And this CRE is giving a lot of guidance that are also applicable to rotorcrafts. So wear and tear factor, I think I have mentioned already this, so I can move to the next one. Stretchers, they are always requested to be compliant to 561, not 562. I think that you may guess why. And we have also to evaluate the vibration level on internal equipments, because they can also have a coupling with the rotorcraft vibration frequency. So this is a list of certification memo that I have mentioned along the presentation. Take the time to have a look at it. I put also some notes of what I am saying and then in the note section of the presentation, so you can have a look later. I just wanted to mention, and this is, we have just 2 slides missing, the challenges for rotorcraft STC holders in the future due to the rulemaking activity that is ongoing. So it's about occupant protections, and it involves seat crashworthiness, fuel tank crashworthiness, and burst strike impact dynamics. Those are being under discussion to understand if there is a need of retroactive application just to improve occupant protections. And also avoid a possible potential crash due to critical system failure. So if you have already an STC that is installed on a non-compliant rotorcraft, the STCs can be fairly affected by those. I cannot tell you what are the outcome of those discussions because they are still going on, but just keep an eye on what is displayed on the EASA website. We have also released recently safety emphasis items and general validation item. Those are almost the same in definition. On the EASA website, when we are receiving a request for validation from the US, they will be subject to this list of safety emphasis items, and we will get involved on the different topics for which we know we have a difference with the FAA in terms of interpretation. Reversely, when you will apply for a validation at the FAA has issued a list, and we have made a coordination on what we think is wise to be issued on both sides. And in this list from the FAA, you will see EASA and FAA interpretation are not the same. So please consider those items when applying for a validation. So conclusion and way forward. So please bear in mind that the Rotorcraft department has the objective to support STC holders in their activity. So don't hesitate to address concern comments as much as possible to us. We want to focus on the fact that STC have impact at local level, but please have a look on the impact at Rotorcraft level. It has to be anticipated. And I would like to say that we have some events coming in the future that will be a very good opportunity for STC holders to address their concern and to present also novel design. We can also discuss about that. It will be the Rotorcraft Symposium, end of 2018, and we will have actually a dedicated workshop for Rotorcraft. It will involve TC holders and STC holders as well, and it will be in January 2019. And if you would like to address suggestions, comments, please use those emails and send us a message. Thank you.